Point is, course is not over. Either you study or I explain or we both collaboratively work. Course is not over. It is not the end. It's just the beginning, I would say. You know all the fundamentals and advanced concepts. Now you need to do lots of research. And for next 2-3 years, we should be doing research in AI because it is still evolving and many new techniques will come. And try to get into industry as early as possible so that when technology evolves, right, we'll be in touch with the technology, right? And in next 2-3 years, right, things will change a lot. And if you look at next 10 years, you will have robots in every home. I can sense that, right? So huge market. Either you do uh, entrepreneurship or you do the job. Huge market it is. It's an opportunity. When things are changing, that's when things are changing and they are tough. That's an opportunity. The problem is an opportunity always. So you guys are well known of it. And okay. So yesterday we looked into language models. Language models means whether you do named entity recognition or parts of speech tagging, or trying to understand the sentence structure. Language model will be there. What is language model? There will be a labeled corpus based on which some probabilistic approach or some deep learning approach will try to make those predictions. So if I show you this, if I take a sentence and pass it to POS tagger, it tagged it with different parts of speech tags. This POS tagger is dependent on some labeled data. Okay, this POS tagger is dependent on some labeled data based on which either it may be using probabilistic approach or deep learning approach. It is actually doing the labeling. So if you look at the probabilistic approach example, this is how it is. So to food, it is trying to find. To find it, it is trying to look at the probability. If the probability is high, or it is looking at different combinations there, and whichever is high, that flag it will assign. And to assign that, we have unigram, bigram, and trigram models, and there are problems of getting zero probability, right? And to avoid those zero probability, we have smoothing techniques. Okay, so unigram may not be always appropriate to assign sequence tagging or independent tagging. Why I'm saying sequence tagging because Ford may be a noun here, and maybe another word. Yeah, so Ford may be noun here, but we saw that saw example. I saw a bird in the woods, and the sawmill is trying to cut the wood. Right, the saw is one way, one place it is verb, another place it is noun. Right, so it is the POS tag is dependent on surrounding words. So you need to do a sequence tagging rather than independent tagging. If you look at the unigram model, it actually looks at independent words probabilities. It is not a sequence probability. Okay. So if you are trying to, like the example I was trying to give here is, you have a corpus where Ford is flagged as noun 6 times, verb 2 times, maybe adjective 3 times. Then you try to assign noun. That is actually unigram way of assigning it. That's not right. It should actually look at the surrounding words and try to do it. So RNN models generally do that in deep learning. Or we have models like hidden Markov model. Okay? Hidden Markov model is one of the statistical models that actually does it. So we look into hidden Markov model. Before we go there, let me try to show a practical, example of this POS tags and other stuff. Okay, so in NLTK, right, NLTK, there is support for different languages here, and you can actually look at each individual tag's total description. So NLTK has got help attribute in it. We have methods. This UPENN, there's some abbreviation here. I forgot. Tag set UPENN. Okay, so you pass the tag and it will give you the description. But NLTK we will not use in production, right? So just for to show you capabilities, I'm showing you. And some people who don't really know that NLTK is not useful in production may ask questions in NLTK also. So for that purpose, I'm just showing. These things may not be useful maybe in a year, because many people will know a lot of stuff there. Okay. So tagged corpuses. So there are in NLTK, there are tagged corpuses for English, Telugu, right? Hindi, Bengali, Marathi, and Telugu, right? Corpus.indian.field IDs. So file IDs, sorry, file IDs. So they, initially when we started looking into NLTK, I showed you the file IDs and stuff, right? So there are tag sets for these languages. Okay. And what we can do with this, you can actually do POS tagging, right? And named entity recognition, you may not be able to do it, but we can build a model to do it. And then, right, briefly I showed you NLTK, then Spacy I am showing you. Spacy has got 65 languages now, right? 65 language support. And it can do parts of speech tagging efficiently, dependency parsing efficiently, named entity recognition efficiently. What is dependency parsing, named entity recognition? We'll see in a moment. So I imported Spacy, right? You need to actually do. Let me run this, and there are steps that need to be done. I think this works. So you need to download. If you don't download, right? If you haven't downloaded the NLTK corpuses, it will show this message. Okay, so to do that, NLTK download you need to execute. See, this kind of a pop-up will open up, and then you should click download. It will download all the modules. It will be around 500 MB. Those modules are. I think we have seen this in our bag of words TF-IDF place, right? Did we? It will take some time. Okay, and then we'll look at Spacy also. We need to install Spacy and Spacy. They call it as Spacy. I always say Spacy, and we need to download the models, language models there. So let us finish this and then we'll go there. Any questions or concerns on the way we are handling the class or the weekend? Saturday, Sunday, both days?
No, sir.
Okay. Why am I asking you? Because if needed, I'll put one more Saturday, Sunday also to if it is needed, right? Mostly I will finish by next Saturday, Sunday.
Okay.
Yeah. I think it took more than a month for you guys, more than 5 months. 5 months, I think it took. We started October 26th, right? Yeah, 5 months it took. income. Okay, so installation is done. So if you execute now, you will not get that error. Okay, so right, that's one thing. And regarding Spacy also, it will say no module found Spacy, right? So now, if you already have installed, if you have already created a virtual environment, you need to activate that. Right, and then you can say Conda install Spacy, right? Like this you can do, or this is one way. If you press enter, right, that will actually execute. The other way is you can actually do it here itself. This is already you opened. I opened this Jupyter notebook in this environment only, right? Initially, I activated this environment, and from there I opened the Jupyter notebook. So I can do, exclamation pip install. Pip will have most recent packages compared to Conda. If you install Conda, install TensorFlow at the command prompt, it will install TensorFlow 2.2. But if you install it here, right, it will install 2.4, the most recent version it will install. So it's always suggestible to install it from the Jupyter notebook as of now. I'm saying as of now because the technology is changing, and these guys, these are all open source modules, right? They'll change whenever they want. Okay, so it is not like Windows technology, right? So we have three, the version 3. I actually built this code in 2.3, I think. And now it's most recent version 3, and there are many advancements in this, right? Once it is done, you can comment it out. So now if I run this, still I'll get an error, right? This is a module I'm actually loading. This is a language model I'm loading. Let me go to Spacy API. See, there are 3 language models: EN Core Web SM, EN Core Web large module and small module are there. Give me 1 second. Language support SM. I forget the names. So if you look at this EN underscore core web SM, right? If you change EN to ZH, it becomes Chinese language model. If you take DA, it becomes Danish. NL, it becomes Dutch. Like that it is. Okay. So here you change this, and that particular language model it actually loads. And give me 1 second. The names I forgot. In the end, right? This EN Core Web SM LG is the large model, right? Large model is going to have like around 40 MB of data, I think. Where is that? Yeah, you see this. EN Core Web MD is a medium model, and it is actually 44 MB of data, right? And if you look at SM, it's 13 MB data, right? What is this data? What is this 13 MB? What is this 44 MB? And large model is going to be 742 MB. What is this MB data?
The corpus. What's corpus?
Corpus size. How big the corpus is, that efficient the model will be, language model will be, right? And when you say web here, they actually took out the crawled data from the web and from the Wikipedia and all that, and then try to label the data. Based on those labels, they are trying to do this. There is a talk to vec, like word to vec. This Spacy has got a vectorization model. Right? Basically, what this does is, if you pass a text to it, it actually converts all the words in it to vectors, and internally it uses vectors only, right? So vectors, 685k keys, 685k unique vectors, 300 dimensional. Understanding what is this? Are you understanding this? What is that? Did you understood this statement? You should be able to understand by now. What is 300 dimensions? When you do word to vec, what happened to each word? When you did word to vec, what happened to each word? It became a vector, right?
Yes, sir.
Like that here also, right? It is actually when I showed you the example of word to vec, I did it 150 dimensional vector, right? These guys are doing 300 dimensional vector. Each word they are actually taking 300 dimension. When your dimensionality increases, right? The number of if you have huge corpus, you should have bigger dimensionality, because there will be distinct words. To distinguish them clearly, you need more numbers. Each word with other word distinguished clearly, you need more numbers. Okay, 300 dimensional vector and 6,85,000. 6,85,000 is the vocabulary size. Okay, so keys and values in this kind of dictionary, that's not a big deal there. Okay, so there is a new model here. I too don't know this one, right? Core web TRF. What is this TRF? We'll see. English transformer pipeline. Okay, so they actually created transformer based word embeddings also. What is transformer based word embeddings? Don't think that I am trying to quickly run through this, but you need to experiment with this. Huggingface.co is the website where they are actually building these transformer networks. Okay, these are all the models. So have you heard about BERT? BERT, BERT? Huh? Have you heard about this BERT? BERT model? No? Yes?
No, sir.
No, right? So this is actually a language model. This is a model that is used. That's a more complex when compared to word to vec. That can be used to train your data on this model and convert your data into vectors. One thing. And Google already, Google and other Facebook and all these guys actually trained these models on their data, like this, LG, MD, and SM. They trained these models, and we have already pre-trained vectors in there. We can actually use those vectors also, right? BERT is a complex model. I'll try to explain the way it works and all that once after knowing RNN, because this is actually attention based RNN based neural networks. Okay, next Saturday, Sunday, the coming Saturday, Sunday, I'll explain you the RNN and the attention mechanism, and then I'll try to explain this BERT a little bit. But no need to understand the architecture clearly, because they are very complex. They're very complex, and at a high level, if you understand, is also fine. In our word to vec, we were actually trying to take the context as the basis, or the surrounding words and the context word as the basis. In BERT models, along with context and surrounding words, we will miss some words in between and try to predict them while training itself. Additional, whatever, right? So it does based on RNN based network. The word to vec is a shallow neural network, shallow DNN network. But the transformer networks are RNN attention based. So they call it as attention is all it takes as the statement for transformer network. It's not transfer learning, it is transformer network. Okay, so we encode, right? This is transformer encoder, right? Transformer encoder. We encode words into vectors. Pre-trained models you can use, you can convert your text into vectors, use those vectors to build your CNN, DNN or RNN, DNN models. Okay, you don't know what is RNN, but RNN is not a big deal. Okay, I'll explain you in next week. Right, so these guys, right, these Spacy guys actually built the transformer network based vectors, and based on those vectors they built a language model. What is that? Right, I'm saying vector representation and on top of it language model. What is that? Can you think? Can you think? Transformer based vectors or word to vec based vectors, on top of it language model. What is language model? Basically it is trying to predict, right? It predict the tags of a sequence, or a particular words tag based on the surrounding words and all. So if you use a machine learning or deep learning model to do that prediction, you need to convert all this text into numbers, right? The way we convert, the way Spacy converts it is either by talk to vectors or transformer based vectors. Why transformer based vectors? Transformer based vectors are more semantically appropriate compared to the shallow network based word to vec vectors. Got it? Any questions? Confused? Clear? Yes, no? All you are upset that I am not ending the class today. Sir? No? So you're understanding, right? I'm actually talking. I'm actually combining all that we learned and talking here. Understanding, right?
Sir, I am actually driving, sir. I cannot speak.
Okay. Carry on. You would have listened to video. That's okay.
Yeah, I can, but anyhow, instead of FM, I just join this one.
Okay, good. So if you look at this French, right? See this here, the model name you want to see, or how to download FR Core News SM it is. See, not Web SM. They actually took news articles and then try to create this, Here also transformer based network is there. Transformer based word embeddings are more powerful compared to word to vec. How to do the code? I'll show you. It is very simple. You just download this, import this Hugging Face model, and then create an instance of these models and then pass your data. That's it. It's very simple. I'll show you. Okay, the technology built to do these models is very complex, but using them is very difficult. That's how it becomes. Maybe in 1-2 years, right, you will get models that will actually represent your text very appropriately. When text is represented in numerical format appropriately, your models become perfect. And our current problem is that we don't have a proper way to convert text into numbers. These researchers are actually trying to find proper ways to convert. See this GPT-2. This is the most famous transformer network. This was actually built on trillions of whatever, right, that data. So here It will be in what you call it as PyTorch. By default, the code is going to be in PyTorch. Transformer GPT to tokenizer, from GPT to to model, and then tokenization. See this? It's very simple, right? Tokenizer I have taken, and using that tokenizer I passed this text, and it actually did tokenization. And then you can take those tokens and convert it into the vectors also, and use those vectors. So using GPT-2 and GPT-3, some researchers are actually trying to build applications that will build web applications, right? You just specify the requirements, like I need 2 buttons. When I click on the first button, it should calculate my PF profit. If I click on second button, it should calculate the tax. If you say, automatically it will build a screen with 2 buttons, and then the code will also, the logic will also be built. People are actually trying to build those kinds of applications. So do you see any danger of AI coming into industry based on the example I gave now? Let me show you that application. Yeah, let me open my WhatsApp. In that I have it. See this,
I remember when I started in 2009 and became an entrepreneur.
Okay.
I was completely.
See that? Say a button that says add $3, and button that says whatever. That guy actually typed it here. Application is actually building. See that? Built a screen. Right? AngularJS, React.js based screen it built. See that? It is adding and subtracting. Logic is also been built there. See that this is the code it built. Let me put it in the group. See, GPT-3 means for developers, right? So try to look at what this GPT-3. GPT-3 is the model, language model they used behind the scenes, which actually converts text into more appropriate numbers, and using those numbers, if you build models like this. So basically, the text whatever user typed, we are trying to understand, the system is trying to understand. Based on the understanding, we are generating this whatever, right? Got it. So can you see any danger? Do you see any danger of AI coming into industry? Yes, no danger.
Yeah, there is a danger, sir.
Yeah, application development, right? It will do.
Yeah.
In coming years, it will do application development. Only that we have to correct some mistakes, or instead of 10 people working on it, 2 people will be working on the web applications or mobile applications, because most of the frame it will build. It may not be able to build complete application by taking the requirements, but it will build the complete frame. No, we don't know. Maybe if we get funding, right, we actually do it. We may do this kind of whatever kind of tool. right? So this is a danger. Don't think that developers' jobs are safe even when AI comes in. Right? The whole landscape of jobs will change with AI. People are not aware, and I would say many people are still sleeping. They should now get up and start learning the new technology and new changing trend. Rather, it will become like call center jobs, right? So our development jobs also become like call center jobs. Only the top-notch guys will get the jobs, and instead of having 10, 15 people team to build a web mobile application, we'll have maybe 2, 3. Okay, AI will reduce number of human workforce in many areas. Okay, so new jobs will create, new jobs will get created. It is always there, but we don't know what kind of new jobs will get created. Maybe helping the AI tool to do whatever. So a person who knows how to explain the requirements to AI tool is a new job, right? Writing a statement that will be able to that this AI system will be able to understand, like writing SQL query. You write SQL query, it returns data. But if a kid writes, right, it will not return because he doesn't know how to write the SQL query, right? Like that. Okay. So things are changing, and most probably in 3 to 5 years we'll have tools which will do this. Especially these new graduates, right? They should be careful of learning technology. They should have this in their pocket and do whatever they want to, but they should brush up and try to become available when the industry needs the people. Now the industry needs people, but so this is one of the biggest things I have seen in the most recent days, which clearly shows the impact of AI. Okay, so these transformer networks are going to change the landscape of it. The way we are converting text, the bag of words, TF-IDF, word to vec, glove, these all things are not going to be used. Transformer networks are the ones we are going to use, or this Spacy kind of models we are going to use. Okay, and then for Germany, Italy, right, everything you have different language models. So here I have installed Spacy now, but I need to download the model also. To download it, you actually need to do this. Python-m Spacy download. This you should do it at the command prompt. If you are doing this on a Windows machine, you should be opening the command prompt as an admin. Okay. So if you have to do this, right, we have to do this at current command prompt, and the virtual environment should be active. On Windows, you should be opening the command prompt as an administrator. Right click, say CMD, right click on the command prompt and then say open as an administrator and then type this command. Rather, it will throw errors. Okay. So now the model is available. Now if I type this, it is doing the POS tagging and auto. No, so sorry, not POS tagging. Yeah, POS tagging and dependency parsing. So Apple is looking to buy UK startup for 1 billion. This is actually a statement in 2015. They actually bought a AI startup called as DeepMind, which built a reinforcement learning based game, Go game player. Okay, it actually won over the Chinese champion. So these guys actually bought it. Okay, DeepMind. So here I took the model, right? I loaded the model into a variable called as NLP. You can take any variable. You can say X, right? And then into X, right, I passed the text. As soon as I passed the text, right, it actually did the tokenization. This document is having some tokens. Each token has got a text, POS underscore, DEP underscore. These are all, dependency parsing and POS tagging and all. So in Spacy, there will be a pipeline. So the documentation is very clear. If you sit there, you can actually finish the whole documentation in a day. Okay, in a day, you can actually understand the whole Spacy. So here, pipeline, processing pipeline, right? So when you actually pass a text into the Spacy model, language model, right? This text is passed into the Spacy language model, a small model I have taken. What is language model? We understood yesterday. Language model is nothing but some probability or deep learning or machine learning based algorithms which use a corpus and try to understand the given data and do the labeling and flagging and all that. Sentence structure. It tries to understand the sentence structure. That's the language model. So every language model will have a pipeline. Tokenization, then tagging. What is tagging? POS tagging, NER tagging, right? POS tagging, then parsing, dependency parsing. What is dependency parsing? I'll explain in a moment. NER tagging, named entity recognitions. It will try to identify the person names, the place names. Default model may identify some, but according to your requirement, you may have to customize your model also. I'll show customization also. Okay. So ultimately, you get a doc object. In that doc object, you will have iterate. You can iterate the doc object. You will have tokens. You can take those tokens, and there will be attributes to those tokens. Okay. That's how this language model actually works. Okay. What is the use of it? I'll show in a moment. Okay. Any questions here? Okay. So, here in this total pipeline, right? I said, parser, right? Parser. What is a parser and what it does? To understand, right? I went back to, I think I forgot to see if the example I do it, but give me 1 second. I'll convert this into PDF and upload. Yesterday I uploaded the IPython file, but today I'll upload PDF also. Give me 1 second. I'm missing one diagram here. CFG, PNG. Okay, so to understand what exactly the parser is doing, I started with context-free grammar. Okay, in 2015, 2016, 17 time frame, right? They used to ask these things in interviews. Now they are not asking. Okay, if somebody really knows AI, somebody really knows NLP, they might ask. Okay, don't worry if you don't understand this. Context-free grammar is one of the uh, to understand the sentence structure, you can use context-free grammar, and there are other approaches also. These are all old approaches, but theoretically knowing them is good. So basically, the context-free grammar is represented mathematically like this: S comma A, right? Variables, A comma B, terminal symbols, right? Production rules, right? There are three things: variables, terminal symbols, and production rules. So instead of looking at A, B, C here, if I show you the English, right, you will understand better. So these are production rules. And this I, he, she, boy, girl, cricket, football, these are all terminal symbols, right? Terminal symbols means in a given sentence, all the distinct words are terminal symbols. Okay, these are all terminal symbols individually, and these are all production rules. The rule 1 is that starting of the string. Give me 1 second. So starting of the string, right? String starts with noun phrase and verb phrase. Okay, and noun phrase can have noun, verb phrase can have verb and noun phrase, right? Verb phrase can have only verb also. There are two rules for verb phrase. For noun phrase, one rule. to begin the sentence construction, there is one rule. Okay, these are all rules that will be used like grammar, grammatical rules. These are the rules that are used, and these terminal symbols will be taken and it tries to form a sentence, right? Suppose that you passed I like football, and you want to understand whether this sentence is correctly formed or not. To understand that, you will take terminal symbols and the production rules, try to build different combinations of these particular words. When you are using different combinations based on these rules, if you are able to produce the string, you say the sentence is correct, sentence structure is correct, right? If you are unable to generate by using these rules, you say the sentence structure is not correct. Got it? It's like mathematics. Language, they are trying to do it as like a mathematics. There are formulas, there are values. You are trying to substitute those values into these formulas and generate the ultimate whatever the string, whatever the the sentence. Got it? Terminal symbols and language, the production rules and variables. Variables are like S, NP, VP. These are all variables. Okay, noun phrase, starting, verb phrase, these are all variables. Okay, got it? Any questions? Understood? No? Yes? Let me explain a little more and start for questions. So S, right, is the starting, beginning of the sentence. It's going to be NP and VP. Sorry, noun phrase and verb phrase. Noun phrase is noun. Verb phrase can be split into verb and noun phrase, right? Or verb, right? If you just take verb, right, I like will come. Right? If you take verb phrase, verb and noun phrase, then you get like football also. So using these production rules, we actually we constructed the tree and then appropriately chosen the terminal symbols, right? So noun I, he, she, right? You can replace here he, she also, but he, she are not generating this particular sentence. So we took I, right? And then there is no verb here. Okay, yeah, verbs are here. Like, read, and sing. So I can put like or read or sing, but read or sing or not is not generating this particular sentence. So like I took, right? Football, right? Football, cricket you can use, right? So noun, girl, boy is also there, right? You can actually replace all those, but one of the combinations is actually generating this particular sentence. So based on these production rules and these terminal symbols, I was able to generate the given sentence. So the sentence is correct. We are trying to give the computer the capability to identify whether sentence is correctly structured or not. Okay, understanding sentence structure can be done using the parsers. Context-free grammar is one of the parsers. Got it? Yes, no? Got it? Any questions?
No, sir, right now.
Okay, good. So here I took an example, right, in NLTK for experimentation purposes. Okay, there is no need for real-time thing. We are trying to understand what is a language model and how exactly it works internally, right? Internally, how exactly it is working. Okay, so maybe at a high level. This is not even in depth, I would say, right? It's a high level. So CFG, context-free grammar, format string. So I actually gave the production rules here. A string starts with NP, preposition, noun phrase, verb phrase, and then the terminal symbols, determinants, nouns, verbs, preposition, right? And then I took a sentence. I shot an elephant in my pajamas, right? I shot an elephant in my pajamas. There is an ambiguity in this sentence, I would say, right? I shot an elephant in my pajamas. That means, as a human being, We know that somebody is in his pajamas and then went out and then he shot an elephant. Is that a photo shot or a gunshot? We don't know. Okay, that is one confusion. The second confusion is, right, if it is a computer, right, it doesn't know what is pajamas, then what it will think is there is some elephant in the pajamas and he actually shot it there, right? So there is a confusion, ambiguity, right? Word sense disambiguation, we call it. Word sense ambiguity, it is called as. And there is a lot of research happening to disambiguate the word sense in a sentence, right? In many languages it will have the word sense ambiguity is going to be there, but there is research happening. It is still in progress work. Okay, so if you have time, right, try to do more research on this and try to find some articles there to solve this problem, because in real time sometimes solving words and words and ambiguities may give more good accuracies. Okay, so based on this particular context free grammar, I am saying it is a context free grammar because there are production rules, there are terminal symbols, and then the states, right, the start state, the variables, the start state, preposition, noun, verb, these are all variables, right? So we have everything here. Using that we can actually do so NLTK chart parser. And which parser you are using? This Groucho grammar, right? Groucho grammar is the parser. I am parsing it. So this is a parser now based out of these grammatical rules. We are actually building a language model here to understand sentence structure. This is a simple example of a language model. Okay, simple example of a language model. So I have taken the parser, and using the parser I am parsing the sentence, right, all the words independently, trying to build construct trees. If I get one tree, these are two trees actually, right? If I get one tree, that means there is no ambiguity in the sentence. If I get two trees, that means there is an ambiguity in the sentence, because whether a person shot an elephant inside the pajamas or within, he went wearing the pajamas, the computer was unable to understand. Okay, so if you get multiple trees of a parse, then there is there is an ambiguity in the sentence, and maybe we need to update the these rules here, these what production rules are production rules. Basically we need to update production rules. Production rules are not appropriate if we already know that sentence is correct, so production rules are not correct. So why am I trying to explain this is sometimes the models may work weird. Spacy model or stanza model or flare model, they may act weird because the rules built inside or the models built inside may not have seen the scenario you are passing right now. Okay, then you need to customize it. Okay, I'll show how to customize the named entity recognition module, not all, right? I like an elephant. This is actually a simple statement. When I tried to parse it, right, I got only one tree. See that? That means there is no ambiguity in this sentence and is clear, right? The sentence structure is also understood clearly. Okay, there are some tools in the NLTK which actually show you how exactly the parsing happens. Recursive dependent parser, right? There is, I have shown you, context-free grammar, and created a parser, chat parser using context-free grammar. There are pre-built parsers, recursive dependent parser, right? How it works? The context-free grammar based parser actually looked into the rules and did it, right? Even this recursive dependent parser also looks into rules and does it, but it actually does it recursively. See that? It opened up this thing, right? You can see, right? Can you see this? So there are production rules here, right? A string starts with NP and VP. Noun phrase can have determinant, noun, preposition, right? A, man, something else, right? Preposition I don't know. Noun phrase can be determinant and noun, right? Some determinant means the man, the person, right? Like that. And then these are all production rules, and then these are all the terminal symbols. And this S, N, P, V, P, these are all variables, right? When I say step, auto step, see that it is actually using those production rules and trying to build a sentence. The dog saw a man in the park. That's what it is trying to build. Okay. So it attempted one way, it couldn't do it. It went back and it started attempting another way. See this? Even the second way is also not working. It's forming something, but it is going out of the total sentence. Actually attempts using rules, production rules, and tries to build the sentence with different combinations of the variables. If ultimately it is able to produce this sentence, that means the sentence is correct according to these production rules. If not, the sentence is not correct according to these production rules. See that it ultimately produced it. The dog saw a man in the park, right? So you can actually step back, or you can actually open that and do step by step also. These are just to play, right? See, it actually started with the production rule S, NP and VP. What is NP? I. Right? NP has got more production rules. It actually took. You can take directly NP's whatever the terminal symbol also. I also you can take here, but there is no I here in the sentence. So it actually tried to do the determinant, noun and preposition kind of split. Now determinant is the, so it actually matched the, and noun, right? Man, no, it didn't match. Park, it didn't match. Dog, it matched, right? It came down, right? And preposition can be splitted as preposition and noun phrase. See this here, the rule. This is the production rule. So what is the preposition? In, right? Did not match. In is not there. Saw, right? Saw is there. Under, with, right? No, it did not match. So it is going back because this is a verb, right? So there should be a verb coming there. So so this is called as recursive dependent parsing. So it actually does, tries different combinations of these terminal symbols based on the production rules. This is one example of a parser or a language model, right? And then there is a shift reduce parser. This actually does in a different way. What it does is it actually shifts. If you say it shifted my, and then it actually tries to find out the, it is a reverse way. In our recursive dependent parser, it is using rules, the production rules, and trying to generate the sentence. But here we take the words and try to find out appropriate variables and then try to form the production rules. Right? Whether this formed thing is actually matching a production rule or not. So we are shifting one word at a time, right? So when I say reduce, right, it will actually combine all of it and then right? So it did not match. So you should get one tree ultimately when you are actually doing the shift reduce, right? We should get one tree. It is not actually forming one tree there. Three trees it formed, right? So we have to actually go back and take a different approach. Okay. So the man, right? The man. Let me reduce undo. Okay. My dogs are a man in the step. Right? My is the determinant. And then determinant and noun should be noun phrase, right? Shift. It is a noun. If you reduce it, it's a noun phrase. Right? Here, if you see noun phrase, determinant and noun, right? Then sa is a noun. So do you have noun phrase and noun here? No. We cannot reduce it. Noun phrase and noun is not there. So we should be going back, and then step, no, not step, undo, shift we should do. So I took saw also because it's a verb. So determinant, noun and verb, do we have anything here? No. There is no reduction. Yeah. So still we are unable to form a single. So it will try different options. The algorithm will automatically try this. Okay, to show you how parsing happens, I am actually trying to show this these tools. Got it? Understood? How these language models are actually identifying whether a particular string is formed properly or not, structurally correct or not, syntactically correct or not, lexically correct or not. These are all same. Structurally, syntactically, lexically, these are all same words. Trying to say that syntactically they are correct or not. Okay, there is another concept called as dependency parsing. This is actually rule-based parsing. So far, whatever we have seen is all rule-based parsing. But dependency parsing is not rule-based. It is rule-based, but it's a different way. It actually tries to do the parsing like human beings. See, some people know how to speak their mother tongue, but they don't know how to write and read, and they don't know grammar, but still they are able to speak language very well. How? Because they listen to it very, from their childhood, so they're able to do it, right? So that's how this dependency parsing works. Okay, it actually takes some examples like these, right? Dependency grammar, and using this dependency grammar, it will try to understand whether sentence structure is correct or not, and which one is dependent on which one. So using this grammar, I can actually understand the structure of the sentence. But here it formed two trees because there is ambiguity in the sentence. If the ambiguity is not there, it would have found one tree only. But if you see, there are no noun phrase, verb phrase kind of variables here. So short is a root word for I, elephant, and in, right? It will say, like, if you look at this, I short, right? So I is a root word for short, right? Short is dependent on I, and then short is dependent on elephant also. Short has got dependency on I and elephant, two objects basically, right? Subject and object. I is the subject and elephant is the object, to which elephant is like an elephant or 10 elephants or 100 elephants, right? That is actually another determinant. And in, it's a modifier, right? In, pajamas is a root word for in, right? My is a determinant. So if you have English knowledge, right, you'll understand better. But as a programmer, right, what I look at is using this grammar. Whenever you send a sentence, it will actually understand the structure. Can you imagine how big the grammar is going to be in Spacy? Is it going to be big in Spacy, the grammar, dependency grammar? Is it going to be big or small? Dependency grammar and Spacy model. It's going to be huge, right? The dependency grammar is going to be huge. Whatever sentence you pass, it is going to do dependency parsing. Okay, these dependency parsers, POS tags, and all these things will be useful when you are trying to build a chatbot on your own. Okay, because you need to understand, what is the subject, what is the object, and all that. Okay, so in Spacy we have a way to see that. This is just for fun. In real time, we may not use it. I passed a sentence and trying to do dependency parsing and trying to render it. See this, if I say display.render, it will show the whole dependency tree, this is dependency parse tree. Okay. And then here, This is very important. So I am traveling from Hyderabad to Bangalore. That's the sentence I have taken. Right? When I try to do dependency parsing, if you see, traveling is dependent on I, am, from, right? And then from is actually from is dependent on Hyderabad and to is dependent on Bangalore, right? We already know that from is like the source and to is the destination. If you know this dependency parsing, right, you can write rules around it. So I'll show you an example here how a chatbot works. Okay? This is just to give you an example, but if we have to build a chatbot on our own, it is very difficult. We have tools to do it. I'll show you. Right? How exactly it does? If you pass this document to Spacy model here, right? I took this. Where is it? I took this. I am traveling from Hyderabad to Bangalore, and I passed it to the model. And then rendering is not a need, right? Travel doc, and the travel doc I am traversing through, and trying to print the token, and trying to look at the ancestors. What are ancestors? These are ancestors. Okay. So traveling from ancestor is Hyderabad and to ancestor is Bangalore, and they are named entities. Hyderabad and Bangalore are named entities, right? They are nouns. They are names of places. So if a chatbot is trying to understand, or it's a travel company's chatbot, it need to know the source and destination. So if you know from and to are the words used to identify source and destination, and next to it, the ancestors of from is a city name, and ancestor of the to is a city name, a location, right? Right, from where to where the person is trying to travel, and you can actually show the tickets available from that place to this place, right? So tokens and ancestors I have taken A, right? Ancestor I am printing, POS tag I am printing, and named entities I am actually looking at. The travel doc, this document will have named entities also. I am printing named entities. Out of all these, if I know named entities and from and to places, I can identify from where the person is traveling to where. Traveling verb, right? And Hyderabad, the ancestor is from, okay, and to where is Bangalore? To Bangalore, the ancestor is to, right? And then I think named entities. Where are named entities? Give you answer. Named entities did not print. Let me try to. Oh, named entities did not came. Why? So let me download this LG model, large model. It is not identifying, the small model is not identifying Hyderabad and Bangalore as named entities. I think we need one more class to explain this. Okay, so let me use that LG model and try to see what happens. Yeah, now it actually identified Hyderabad and Bangalore as entities. See the difference? Small model cannot identify everything because the corpus is small. Right? The big model was able to identify the Hyderabad and Bangalore as named entities, and we know the ancestors are to and from, right? So take the named entities in this loop and try to identify ancestors. And if it is from and to, you know the source and destination. You can actually show the tickets available from source and destination. Understood? How we can use Spacy to, kind of understand the text, human text. Any questions there? Simple example it is. Any questions? No? Move on. Is it enough for today? Is it enough for today? Shall we meet next week, or are you okay if I? Sir, you're all silent.